Good morning, everyone. Good morning. Shall we begin the session? Yes, today's topic is data type. That is just a revision of the data type, but we have covered the data type. What are the various data types that is available in this one? That is the data types revisited. In this, there are multiple integer, long and short, integer signed and unsigned, char signed and unsigned, float and double, few issues. What are the various storage classes in the C? That includes the automatic storage class, register storage class, static storage class, external, and wish to when or wish to use when. That is when what is the condition when to use the storage class, register class, or the static class, right? So first one is a various variety of data type that is available. That is known as a char, int, or float. That these are the default, or we can say the predefined data types. So these are the three basic data type, or we can say the default data type that is available. So these are the primary data type, that is a char, int, and float. And we already discussed about this. Int takes 2 bytes, char takes 1 byte, and the float takes 4 bytes. Char is only used, or char is used for the characters, and int is used for the numbers, and float is used for the decimal number. So we already discussed about the int, char, and float. It may be seen or to how many or how C programmers manage with a tiny set of the data type, that is the C programmer are really deprived. They can derive many data type from these data type. That means int, can, float are the primary, and can we can derive the next data type from the next data type from the unnecessary data type. So in fact, the number of type that is used, so there are multiple types of the variable that is available in this. So char could be of the unsigned char, or the signed char, or the int can be of the short int or the long int. Next is the integers, long and the short. For the 16-bit compiler like Turbo C or the Turbo C++, the range is -3 to 7687 to the +3 to 7687. For the 16-bit compilation, for the 16-bit compiler, we are also using the one of the range that is using with the 32-bit or the 16-bit compilation. Then remember that out of the 2 or 3 bytes used to store an integer, the highest value is the 16th and or the 32nd bit that is used to store the sign of the integer that is used or available for the int or the short or the long. Now, short are at least 2 bytes big, longs are at least 4 bytes big, shorts are never bigger than the ints are never bigger than the shorts. This is available as we can say the comment. So ints are or the shorts are at least 2 bytes big. So short must be of the 2 bytes long, then long of the at least 4 bytes big, then shorts are never bigger than the int, then ints are never bigger than the longs. This is a 16-bit compilation. This is a 32-bit Visual C++ or the C++. Then long integer also cause the program to run a bit slower, but the range of values that we use is expanded tremendously, and the values of a long integer typically can vary from this one to this one, and more than this you can also you should or not use unless you are taking the world census. If there are such things as longs, symmetry requires shorts as well as integer that needs less space in the memory. That will help speed up the program execution. Short integer variable that are declared as a int, float, or the long. The next is integer signed and unsigned. That may be positive or the negative. There are two ranges, -3 to 7687 to this one, and 0 to 65535. That is the unsigned int and the signed int. So this is the unsigned int I, unsigned I. So like an unsigned int, there also exists a short unsigned int and a long unsigned int. By default, the short int is a signed short int and long int is a signed long int. Now, next one is a char, that is of the signed and the unsigned. That is parallel to the signed and unsigned integer. That is either short or the long, and that also exists the signed and the unsigned chars, both occupying the 1 byte each. So that means char takes 1 byte for the data. So this is one of the example. We are taking the variable ch of the char type that is stored in a, that is stored the value as a. Here, what gets stored in the ch is the binary equivalent of the sky value of the a, that is a binary of 65, and 65 binary can be stored. Then the binary can also be stored in a signed char. And this is same as the ordinary char and its range. This is from -128 to the +127, and the unsigned char have a range from 0 to the 255. and that is used with the main function. So char ch equals to 291, then printf ndc ch. There are two variables that is used with this. Now, what output do you expect from this program? Possibly 291 and the character corresponding to it. We are not, or well, not really surprised. The reason is that ch has been transferred or defined as a char, and the char cannot take a big value from the 127 because it is already available that the char does not take more than 127. So we are not able to take the values more than 127. This is another program that will make the concept clearer. This is the main function char ch for ch equals to 0, ch is less than equals to 255, ch plus plus, then printf. This is d, c, ch, and ch. Now program should output the sky values and their corresponding characters. This is also the indefinite loop that ranges from the char to the int to the float. Now, next one is a float and the double. There are two concepts that is used that is available with the float and the double. Float takes 4 bytes and the double takes 8 bytes. So when we use the float, it takes the 4 bytes in the memory and the double takes 8 bytes in the memory. And the variable of the type double is declared as this same. Like we are using the int, like int a comma b, in the same way double a comma population. And if the situation demands usage of the real number that lies even beyond the range offered by the double data type, there exists a long data type or long double that can range from this one to or minus 1.7e to this one plus 1.7e. That is exponent. Now this is the main function. This is the char c, unsigned char c, int I, unsigned int j, then short int k. These are the various data type that is declared over here. Then char, scanf, percentage c, c and the d, then printf. This is c and the d. And again it is using as the scanf and the printf. Again it is using as the scanf and the printf. Now this is the data type, this is the range, this is the byte, this is the format. This is the signed char that ranges from minus 128 to the 127. This is for the 1 byte, and format specifier is a percentage C. The unsigned char 0 to 255. This is also 1 byte. This is percentage C. Then short signed int minus 32768 to the plus 32768. This is takes 2 bytes because int takes 2 bytes. That may be assigned, that may be unsigned. So this takes 2 bytes, and the format specifier is the percentage t. Then again short unsigned integer that also have a 2 percentage u. It is taken out. Then signed int. Then unsigned int that also takes a 2 bytes, then long, this takes 4 bytes, float takes 4 bytes, double take 8 bytes, and the long double takes 10 bytes. This is used as a LF, capital L, then small f. This is the small L and the F. The sizes and the ranges of the int, short and long are compiler dependent, and the sizes in this figure are of the 16-bit compiler. Now these are the few issues that is available with the data type. These are the few dicey issues that is used. So there are a few primary data type that is used that takes a look at some more related issues. We saw earlier the result of the or the size of the integer that is a compiler dependent, and this is even true in case of the char and not the float. And also depending upon the microprocessor for which the compiler target its code, the accuracy of floating point calculation may change. That change the calculation, that change the currency population that is used to the floating point. For example, the result of the 22 by 7 would be reported more concisely or accurately by VC++ compiler. And if you look at ranges of the chars and the int, it seems to be one extra number on the negative side. The next one is the storage classes in C. What are the various storage classes that is available in C, or how we can store the data? To fully define a variable, one needs to mention only that its type, but also the storage class. In other words, not only do all the variables have a data type, they also have a storage area. We have not mentioned storage area yet, that we have written several programs in C, and we are also able to get away with this because storage class have some default, and if you do not specify any storage class in the declaration, then the compiler will assume a storage class depending on the contents. That means, for example, if I'm not using any storage class, if I'm not defining any storage class, so it is taken as an automatic storage class. And from C compiler's point of view, a variable name identifies some physical location within the computer where the string of bits or the string of bits representing the variable value is stored. And there are two types of or two kinds of location in a computer where such a values may be kept. One is a memory, one is a CPU register. So there are two data that is used by the captured by the memory by the computer. One is a memory, one is a CPU register, and it is a variable storage class that determines in which of these two locations a value is stored. And moreover, a variable storage class also tells us where the data would be stored or where the variable would be stored. What will be the initial value of the variable? If initial value is not specifically assigned, that is the default initial value. What is the scope? So what is the initial value of the variable? What is the scope of the variable? That is in which the functions of the values would be available. What is the life of the variable? How long the variable exists? That is the life of the variable. Now there are four storage classes that is available in C. So if I'm talking about the storage classes, there are the first types of storage classes in the C language. One is the automatic storage class. So if we have given nothing, that means that is an automatic storage class. The next one is a register storage class. Next one is a static storage class. Last one is external storage class. So there are the four types of storage classes that is available in the C language. Now let us examine these storage class one by one. So first one is an automatic storage class. The feature of the variable defined to have a automatic storage class that are as under. So this is the storage, that is a memory. What is the default initial value? An unpredictable value, which is often known as the garbage value. That means whenever we are using the storage class that is automatic, so it takes the garbage value as the automatic value or the default initial value. Then what is the scope? This is local to the block in which the variable is defined. Local to the block in the sense local to the data, like local to the looping in which the variable is defined, that is the scope of this. What is the lifetime of this one? Till the program control or till the control remains within the block in which the variable is defined. So this is till the control remains within the block that is available within the block, that is the lifetime of the storage class. So one is the storage, that is the memory. Then default, that is any predictable or unpredictable value, that is often known as a garbage value. Then scope, this is local to the block, which is often known as a variable. Then life, till the control remains within the block in which the variables are defined. Then this is a program that shows how to use the automatic storage class. This is the main. Then auto int ij, then printf percentage n ddij. Now the output of the above program, that would be 121 1221. This is the garbage values of the I and j. And when you run this program, you may get the different values, since the garbage values are the nothing but are the unpredictable. So always make it clear or to the point that you initialize the automatic variable property, otherwise you are likely to get the unexpected result. Because if you are not defining an automatic value, that will get another value that is by default value. No, that is not available. So you may define the storage class as auto, that is AUTO, not the automatic. So you have to define the keyword AUTO, that is auto, not the full word, that is automatic. Now the scope and the life of the variable, whatever the scope, whatever the life of the automatic variable, that is illustrated in the following program. This is a program shows how to use the automatic variable or how to define the automatic variable. So this is the main. Then auto, that means we are using the auto storage class that contains or that defines the value as a int I equals to 1. So this is taken as a I equals to 1 with this one. Then auto, then again this is printf percentage di. So this is used as I, then printf percentage di, then printf I. That means we are using the storage class as auto, that is used as I. Then again it is used as I, again it is used as I. This is the output of the following program that is defined over here. This is because all the printf statements occurs within the outermost block. So the block is all the statement that is enclosed within the pair of the braces. So this is available within the pair of the braces in which the high has been defined. It means that the scope of high is local to the block in which it is defined. In the moment the control comes out of the block in which the variable is defined, the variable and its value is relatively low. That is variable is defined, that is low relatively, that is variable is defined for this variable only. And to cache my point, go through the following program. This is the auto that is available with the counterpart. The next part is a register storage class that is of the register type. So this is defined of the register storage class that are defined as under. So this is defined as under storage class. Now what is the storage? That is a CPU register. So we can store the data in the CPU registers. Then the default initial value, that is the garbage value, then scope, this is the local to the block in which the variable is defined, then life, till the control remains within the block in which the variable is defined. So till the control remains the constant. Now this is the register. We can use the register for storing the values in which the data is defined. Next one is the static storage class. In this again we are using the static storage class. So that is next one is the static storage class. That means we have done with the automatic. Now next one is the static. That means we are using the static. Now what is the storage? That is a memory. The storage is a memory. What is the default initial value? That is also a 0 in this case, in case of the static storage class. Then scope, this is local to the block in which the variable is defined. So this is local to the block in which the variable is defined. Then live, this is the value of the variable that persists between the different function calls. So this is a live, or value of the variable that also available or persists between the different function call. Now compare the two program and their output. Now let's see what is the difference between the automatic and the storage class or the static storage class. This is the increment. This is the static int I equals to 1. This is the auto int I equals to 1. Like auto variables, static variables are also local to the block in which they are declared, and the difference between them is the static variable does not disappear when the function is no longer active. That remains a constant because as a name advice, static, that means this remains a constant till the variable is declared, till the function goes on. So they do not vanish when the function gets off. In the above example, when the variable I is auto, each time it increment, it is reinitialized to the 1. When the function terminate, I vanishes and its new value of 2 is lost. The result is that no matter how many times it is incremented by 1, it is initialized to the 1 every time. And on the other hand, if the I is static, it is initialized to the 1 only once it is initialized again, and during the first call to increment, I is incremented to the 1. This is a program that's seen that is running an address of the k from the function and collecting it in the j. Therefore, the j becomes a pointer to the k. Therefore, using this pointer, we are printing the values of the k that is currently prints the value as a 35. Now next one is external storage class. So one is automatic, one is a static. Next one is external storage class. In this feature, there is a storage class that is defined. Now storage is a memory, then default initial value is 0, scope is global, and the life is as long as the program execution does not come to the end. This is one of the variable. This is one of the example that is given, and this also says that the external variable also different or also differ from the data. This variable differ from those we have already discussed in the scope, that is the global or the local. These are declared outside all the functions, but these are available to functions, but they are defined outside the function that care to use them. This is an example to illustrate the fact. This is int I main printf I equals to %di increment decrement. This is the increment function, definition of the increment function. That is I equals to I plus 1, printf non-incrementing I equals to %di. Then decrement I equals to I minus 1. So the decrementing the value that is also represented with the I. Then the output would be I equals to 0 on incremented. This is 1, 2, then 1, 0. Now look at the following program. This is x equals to 21. This is the main function extern int y printf %d xy. This is the main function that is given below, that is available with the data that is used with the data. Now these are the or the x is defined at the two places, one outside the main, one is inside the main, and when the control reaches the printf in main, it gets printed. And when display is code and the control reaches to the printf, there is no such conflict. And this time the value of the global x, that is 10, gets printed. Now, wish to when use or wish to use when. That means either we are using the auto, either we are using the static. So wish to use when. So Dennis Ritchie has made available in the C programmer a number of the storage class. So wish to use when with a different storage class with the different situations, with a view to economize or the memory space. That means reduce the memory space consumed by the variable, improve the speed of the execution of the program. So we can economize the memory space consumed by the programmer, and we can also improve the speed of the execution of the program. Now the rules are as under. This is the rule that is available. Use the static storage class only if you want to, if you want the value of a variable to persist between different function call. Then use the register storage class for only those variables that are being used very often in a program. The reason is very that the few CPU registers are at your disposal, and many of them might be busy doing something else. Now, using the external variable, that is also used for storing or for the variable that are being used by almost all the functions in the program. That would avoid unnecessary passing of these variable as argument when making a function call. And when we declare the program a variable as external, that would amount to a loads of wastage of the memory space, because these variables would remain active throughout the right of the or lifetime of the program. That is used with the auto storage class, that is used with the auto variable. This is a summary what we have covered. This is exercise that is available with this. Now this is the next chapter is C preprocessor. Chapter with